Okay, so today we're going to talk about functions. A function is a relationship that pairs each input value with exactly one output value. That's the definition. In a relationship between variables, the dependent variable changes in response to what the independent variable tells it to. Okay, our dependent variables are typically y, and our independent variables are x. Okay, we use the vertical line test. Okay, to see if the graph represents a function. If the vertical line intersects the graph more than once, it fails the test and is not a function. Equations that are functions can be written in the form called function notation, and we're going to talk more about this later on in these notes. Okay, function notation. Okay, it is used to find the element in the range that would correspond to the element in the domain. Okay? So it says determine whether each one of these are functions. So when we do this, we look at the x values only. So we look at each one of these x values. And we look to see, do any of the x values repeat? In this case, no, they do not. So no x values repeat. So therefore, this is a function. That's good. It is a function. Okay, whereas this one, okay, all of these, those are all the same number. Okay, so x values repeat here. So this is not a function because those x values repeat. Okay? When we're talking about a graph, we use the vertical line test. If I draw myself a vertical line like I did here, and I hit the graph in more than one place like I do, then this is considered not a function. Okay, so that's not a function. Whereas this one, if I draw a vertical line, no matter where I draw it, you notice I only hit the graph every time one time. That's okay, so this is a function. Okay, same with this one. That one I'm good here, I'm good there, but if I draw one in the middle, I notice I hit those dots more than once, so therefore this is not a function. Okay, and that's because of the vertical line test. All right, let's talk about function notation. Okay, function notation. Okay, we're not going to do all of these. We're only going to do some of them. So we're not going to do this one for sure. We're not going to do this one for sure. Okay. So the first one we're going to do is this one that says f of 5. And what this is telling me is that x is 5 in this case. So I'm going to replace x with 5. Okay, once you do that, you don't do anything to the left-hand side. You only do it to the right. So negative 2 times 5 is negative 10, and negative 10 plus 11 is 1. So that is basically telling me that my y, because remember f of x and y are the same thing, my y is equal to 1. Okay, and this is again x. Okay, let's try another one. This one says f of negative 3. So that's telling me that this is x is negative 3. So in my equation here, I'm going to replace that x with a negative 3. Okay, and then I'm going to simplify. Negative 2 times negative 3 is 6, and 6 plus 11 is 17. So what I'm saying is when x is negative 3, y is 17. Okay, let's look at the ones on the bottom. Okay, so again, we're given f of 2. F of 2. So that's saying that x is going to be 2. So every time in this equation that I see an x, I'm going to replace it with 2. So I'm going to have 2 squared plus 3 times 2 minus 1. And then we have to simplify. So 2 squared is 4. Because order of operations tells us to exponents first. Then we're going to multiply. So it's going to be 4 plus 6. Okay, 4 plus 6 is 10, and 10 minus 1 is 9. So remember, that's going to tell me that y is 9 when x is 2. Okay, let's try another one. Okay, the next one we're going to do is when is f of -1. So that, again, that number inside is my x. Okay, we're going to use this equation, so every time I see an x, I'm going to replace it with -1, so it's going to be -1 squared. That's 3 times -1 minus 1, and we just simplify. -1 squared is 1. 3 minus times -1 is -3 minus 1. 1 minus 3 is -2, and -2 minus 1 is -3. So again, y is -3 when x is 9. Okay? We're going to go ahead and skip this one for right now. Actually, no, we'll go ahead and do this one. Okay, so remember we talked about creating a table in x, y. Okay, we're going to do that for both of these. Okay, we're going to choose x values. Now we just choose 0, 1, and 2, 3 of them. Okay, and what we do is we replace these x values into this equation where x is to find our y's. So let's do the first one. So it's going to be, we said it's going to be 0, so it's 3 times 0 minus 4. 3 times 0 is 0. 0 minus 4 is -4, so that's going to give -4 there. Then we're going to do the next one. The next one was 1. So we're going to replace x with 1. 3 times 1 is 3, and 3 minus 4 is -1. So we're going to go ahead and put a -1 there. Ooh. And then the last one is when x is 2. 3 times 2 is 6. 6 minus 4 is 2. So that last one is when y is 2. Okay, then we're going to graph each one of these points. 0, -4 is here. 1, -1 is here. And 2, 2 is there. And then because it's an equation, you have to put a line through them. And put it on each end. So the same thing on the other side. The first one is when x is 0, so it's -4 times 0 plus 1. So it's going to be 0 plus 1, which is 1. So 0, 1 is our first one. Second one is when x is positive 1, so y equals -4 times 1 plus 1. -4 times 1 is -4, plus 1 gives me -3, so y is -3. The last one was x is 2. Okay, so it's -4 times 2 plus 1, which is -8 plus 1, which gives me -7. Okay, so we're going to graph each one of those. So 0, 1 is here. 1, -3 is here. And then we can't go to -7 because we don't have enough room on the graph, but that's okay because if we have 2 points, we can graph a line and we connect them. And there we go. And then it says write a function rule to model the cost per month. When we write functions rules, it's always in y equals mx plus b. B is always our constant, so in this case our constant is 24.99. Okay, when you see this word per, that stands for our m value, so our m value in this case would be 5, and then the x just comes down, the y comes down, everything else comes down, and there's our equation.